go. Let's go. All right. So, how are we going to do this? Number 6. First step. To find the P of the circumcenter. The circumcenter is when you take the circle where the points go through the vertexes of the triangle. Okay? So, each part of the original triangle is going to touch the circle. From that, you're going to find P. P is, how you find P is you cut the triangle, the original triangle, which was black, in half. You're going to find this, the bisectors of each side of this triangle. So this X creates a perpendicular bisector, which means this side is congruent to that side. Okay? This side is congruent to this side, and this side here is congruent to this side here. Okay? So CY is congruent to BY, and BX is congruent to AX, and CY, oh we did CY, so AZ is congruent to CZ. So that was our first step. And how did we do that? By creating the segment perpendicular bisectors. Okay? So not only did we bisect it, but we created perpendicular bisectors. So I'm going to change those colors from blacks because it gets a little confusing. The green. So this was the perpendicular bisector. This was a perpendicular bisector. This is a perpendicular bisector. Okay? Then, what we did was, we're going to determine a few triangles, a few right triangles. The first one's in blue. That's this one. So, because P is outside the triangle, we know that this one is obtuse. Alright? So we know that the triangle is an obtuse triangle because P is found outside of the triangle.
What is that thing next to the A?
And. Dot.
No, like...
This?
No, the A.
This?
Right.
Z.
Ah.
So Z. I like my Z's with the line in them so that they don't look like twos.
If you make them in straight lines, they don't look like twos.
Okay? So you still look like twos. That looks like a 2 to me. Right? A lot of times. So kids get, even if you do this, sloppy 2, still kind of looks like a Z. So my Z's always have this. Always, always, always. You'll find them in the book that way, that also, a lot of the times. Z's will have the line in the middle of them. Okay? Alright, next. So I know it's obtuse. I'm going to find another right triangle. The other right triangle is with this guy right here, XP. Right? So XP creates another right triangle, but the important right triangle that I'm trying to find includes the radius of the circle. Right? So I did that one in red from the last film. I don't know if I'm going to publish the last film, but if I do, that way it will be there. But this is your red right triangle. Okay? So right now we have a blue triangle, a right blue triangle that we call P, Y, B. Or let's call it PBY. And that's because I wanted the PB to be I always want to start with the radius. So PB is your radius, And that's going to be equal to all the other radii. And so PBY is blue. AP. So PAX is red. Okay? Another right triangle is PA, another radius, X. Okay? And then the last one, I think we made green, if I'm not mistaken. Or did we? Blue, purple. So the last one we made purple, and it went from C to P, right? Okay, and then of course it went to Z and came down this way. So, okay, so that is your next one, the purple right triangle of PC and then Z. All right, and all of these have radius, so that means the radius PC is congruent to PB, which is congruent to PA. Okay? So all those are what we call radii. So your second step, let's just do second step in blue. Your second step, how do we know these are perpendicular triangles? Because it's the definition of a circumcenter. The definition of a circumcenter says that these are cut in half, and we create the perpendicular bisectors to find the P. So that's how we were able to create these, using the definition of circumcenter. Okay? Next, again, the definition of the radius of a triangle. Okay, so purple 3 is going to be the definition of the radius of a triangle. Oh, sorry, radius of a circle. Sorry about that. Next, the other thing we need to know is that, well, I also know that BX is congruent to AX, right? Because we cut that in half. That whole segment of the bisector thing, right? So I can do it in green, level 4, which is BX is congruent to AX, or yeah, let's do AX. And AZ is congruent to CZ, and BY is congruent to CY.
Find more space.
And right now we're finding everything that we know is congruent. And the things that we want to know about right triangles, where are the right triangles, and what's apparent about the right triangles. We know that these sides are important. Now, later on in chapter 6, we're going to be able to find any side of these triangles and any angle of the triangles using SOHCAHTOA, right? So, but we don't have SOHCAHTOA yet, so we're not going to go that far. Right now, in the last problem, we worked with all angles. We used a bisecting angle theorem, right? So when they gave us angles, we could find angles, right? With this one, they give us sides, so we can find sides. And that's the key to this one, okay? So, on this problem, in problem number 7, so this was problem 6, we solved it, and now problem 7, we're going to use what we did for 6, okay? And continue with problem number 7.
What is the last B? BY?
BY and CY. Yep. Alright, so they said AX is equal to 10. Right? Yeah. Okay, so AX, the measure of AX is equal to 10. Okay? The measure of AC is equal to 20. The measure of BY is equal to 8. And the measure of AP is equal to 12. Now, this is given. Step 5, sorry about that, 5. Step 4, sorry about that. Step 4, what did we use to find step 4? The green step. Well, that was the definition of circumcenter, or the definition of a segment bisector. Okay? So when you bisect a segment, we know it's cut in half. So we know that those are all equal.
But does that say BRB?
This?
No, in the red, the given.
BY
Oh,
is equal to 8. Okay? Now, they want you to find the measure of AB. The measure of AB. So let's think about AB. What is AB? So let's plug these numbers in first of all. AX. Where's AX? That's right here, right? So that's 10. Does that make sense? And if this is 10, and these are congruent, so this has to be 10, right? So that means that BX is 10. Does that make sense? Okay? So now I know that this is 10, and this is 10. So AX is 10, and that is 10. Right? Okay. Next. What else did they give us? AC. So the whole thing, right, is 20, right? AC is 20. Okay? And then they give us BY. BY. So that's just this piece right here, and that's 8. Okay? So if that piece is 8, then underneath this piece is 8, right? So CY is 8. Okay? So if BY is 8, then CY is 8. Right? The one we don't know is AZ and CZ because we know AC. Does that make sense? We know what the A to C is, but we don't know the half of it. The half of it. What's half of 20? 10. Yeah, so if AC is 20, then AZ is 10. Okay? So that means this is 10 and this is 10. Okay? So that means this is 10 and this is 10. So when they ask us to find AB, can you find AB yet? AB is equal to what? BX plus AX, right? So, segment addition postulate, right? What's next? Substitution? Do we know what BX is? 10. 10. AB is equal to 10 plus 10. Substitution. Measure of AB is equal to 20. Simplification. Okay? That was 7 part A. 7 part B. It asks AZ. AZ is equal to what? Well, AZ is equal to AC minus CZ, right? Okay, do we know any of these numbers? We know AZ is 10. So this is segment addition postulate. In other words, if we wanted to, we could just write this again in another way where AC is equal to AZ plus CZ. So why don't we write it that way? AC is equal to AZ plus CZ, right? Segment addition postulate. So what is each one? Do they give us any of them? And didn't they give us the 20 AC? So they said this was 20, right? And they said these are equal because AZ was equal to CZ. So this is equal to AZ plus AZ. And which one do they want us to solve for? Did they give us AZ? We found it to be 10, but they didn't give it to us yet, right? So we substituted in AZ, substitution, and then that would be 20 is equal to 2 times AZ, right? And then how would you solve for AZ? This is simplify, right? Divide by 2. Yeah. So divide by 2. And you get 10, right? And go, okay, then that's division property of equality. Okay? And that's AZ. What did they want it? Yeah, they wanted AZ. So there you go. There's AZ. Okay? There's AB. Okay? That was B. And then C, they wanted find YC. So C is YC. So find the measure of YC. Okay? What's the measure of YC? Well, YC and B